Well, hello, everybody. We are trying to practice our factoring. So, like I said, summer packets were due, turned in. We have been practicing factoring since the beginning of the year, and we will have factoring quizzes until we've all mastered the skill of factoring. And in Algebra 2, factoring is super important. So, we're going to practice in this one 4 different types of factoring. Again, the first style is factoring out a greatest common factor. This is our equation. Notice 2 terms. You're going to leave a space. You should open a set of parentheses. Then we want to look at these numbers, 5 and 6. Do they have any greatest common factor? Let's see. No, there is none, and that's okay. But then the next thing we look at is look at the variables. Notice how there are 2 variables. Each term has a variable. The one that's smaller is x to the power of 1. So that is something we can factor out since they both have x's. We factor the smaller one out. We go ahead and now we divide each term. So a little polynomial division. Whatever's left, the remainders end up coming down here. So 5 divided by 1 is 5. And then we have x to the power of 2 divided by x. Base stays the same. Subtract your exponents. So 2 minus 1 is one single little x. Minus, well, the 6 comes down, and the x's cancel out. There we go. That is your final answer. Basically, if you sit here and you were to distribute it back, you go right back to your original problem. That's what the purpose of factoring is. Take a bigger problem, break it into smaller pieces. This one we might look at and also say, hey, this has to be greatest common factor. But the problem is there is no number that goes into both 81 and 64. Both terms do not have x's, but what we should notice is that there is something special here. Look at that number. We're trying to notice patterns. 81, 64, x squared. They're all perfect squares. So this falls into our difference of squares. Basically, we're going to open up 2 parentheses. Right? And the first thing we do is put a plus in one, put a minus in the other. There is no middle term here, guys, right? The x term, if you think about this, ax squared, it's a standard form of a quadratic, plus bx plus c. Right? That middle term, the b term, is gone. So somehow they cancel. That's what this plus and minus happens. When you multiply it together, the middle terms cancel out. But now to fill in the rest of the pieces, super easy. If you notice these are all perfect squares, all we do is we take the square root. Square root of 81, 9. The square root of x squared. Square cancels. The square leaves you with an x. Great. We duplicate it. And then we just take the square root of the last term. Square root of 64, 8. And if you're not good with your square roots, but you should be, use a calculator. Perfect. That is fully factored. If you sit here and you were to FOIL it or box method it back together, you would end up with your original. Hey, there's 2 forms of factoring. Greatest common factor. And then we have here is the difference of squares. Our most common factoring, though, is a quadratic trinomial. Many different ways to do this, but every way starts the same. And I would like us to learn my way so that we can speed up our process in factoring. First things first, no matter what way you do, we always have to start with our organization. A times C. Again, this is the standard form of a quadratic. We notice our B will be put down here. So B is negative 26. Right? A times C is negative 27. Yes, the signs are important. So the easiest way to do this is to start listing your factors of 27. 1 and 27. Okay, 2 does not go into 27, but 3 does. 3 times 9 goes into 27. And then you keep going down and saying, hey, does 4 go into 27? So 27 divided by 4. Nope, that doesn't go in evenly. 5 doesn't go in evenly. 6 doesn't go evenly. 7 doesn't go evenly. 8 doesn't go evenly. And if you go to 9, hey, we already used 9. So those are all the listed factors of 27. But notice, that's negative 27. So that means one of these two numbers has to be negative, either the big one or the small ones. And notice what happens when we add them together, we're supposed to end up with a negative number. So that means the bigger number is negative. Okay, so there's our fancy factored pairs, the ones that multiply together to give us negative 27. Do any of these two pairs, when you add them, you get a negative 26? Yes, that's this set right here, a 1 and a negative 27. We are ready to stash our pieces. So we have a binomial. We're going to use 3x. Don't worry about that part. Just the 3x. We stash a 3x in each of our binomials. Then we stash these magical factors we just found. So positive 1 plus 1, negative 27 becomes minus 27. All right, we're almost done. Now is our trash time. Time to take out the trash, our trash factors. Are there any common factors? Any common factors between 3 and 1? No. No problem. Just copy that down. Great. 3x plus 1. That's part of our solution, or our factored form of this quadratic. Okay. Now we look 3 and 27. Is there a common factor here? Yes. 3 goes into both of those. So we're going to just trash this factor, divide it out. These cancel. That leaves us with the next. These leave us with a negative 9. Okay. The next thing we have is our grouping. So right here, when we have factor by grouping, we look at this and we say, oh, how can we tell? What should we do here? How do we even know we should use grouping? Notice there are 4 terms. That's an indication that you're ready to factor by grouping. So what do? We bring them into 2 separate groups. There's one group, and here's another group. We're going to treat these as a greatest common factor, leave a space, open a set of parentheses. And then we're going to do a greatest common factor again for the second 2. Leave a space, open a set of parentheses. Okay, so we look at these. You look at the numbers, 1 and 2. Well, they don't have anything in common, right? Other than 1. Doesn't do us any good. Do they both have x's? Yeah, this x is the smallest one. So we can factor out an x squared. So if I factor this out, just like greatest common factor, we go ahead and we divide, a little polynomial division. Right? 3 minus 2 is a single x. The 2 can come straight down. These 2 cancel. Anything divided by itself is a 1. And now we have to do this one here. Now here's the catch. Whatever we get in here needs to perfectly match this one. So we look, what does negative 22 and negative 11 have in common? Oh, look, negative 11. I can divide this by negative 11, and I can divide this by negative 11. These will cancel and leave me with a 1. These cancel and leave me with a 2, and the x comes straight down. Notice what's in the parentheses is exactly the same, so that's part of our solution because it's a common factor again. So we can cross these out, and whatever's left, which is this and this, that's what we put in our final set of parentheses, x squared minus 11. There you go. That's how you do these. If you want to see another one really quickly here for the grouping, look. The only thing this has in common is x squared. Divide each piece by x squared. Leaves you with an x minus 1. Here, I can factor out a -2. If I divide this entire term by -2, I'm left with x minus 1. Again, see, it's the same. So you know that's one of your factors. Bring it down, cross them off. Whatever's left, that's what goes in your second binomial. X squared minus 2. And like that, guys, you are done. All right, you need to practice these. Have a great one. Get ready for your next factoring quiz.